The frontiers of space have given us some iconic images of exploration, such as Apollo 8's Earthrise view of our world from the moon's orbit, Buzz Aldrin's photograph of a footprint on the lunar surface. But both of those pictures were taken before human eyes first saw one of our planet's greatest geographic features, an undersea volcanic rift called the Mid-Ocean Ridge, which meanders for 60,000 kilometers around the globe at an average depth of 2,500 meters in the deep ocean. Now, we've long known about a little bit of the Mid-Ocean Ridge where it sticks up out of the water to form Iceland, but the first vehicle to reach the deeply submerged Mid-Ocean Ridge did so south of the Azores in 1973. That journey took place during a joint US-French project called FAMOUS, which stands for French-American Mid-Ocean Undersea Study, and it took place 4 years after Apollo 11 touched down on the moon. Since then, further journeys into the ocean depths have revealed wonders such as undersea volcanic vents, like these, first encountered in the Eastern Pacific in the late 1970s, along with lush colonies of deep-sea creatures that thrive around them. Now, the pools of light around our deep-diving vehicles give us tiny and fleeting glimpses into a vast realm of darkness. But we're now able to dive deeper, stay longer, and visit the deep ocean more often than ever before. So for the first time in history, the half of our world that's been hidden by water more than 3 kilometers deep is slowly becoming known to us, and just in time for us to chart a future course among its economic opportunities and environmental challenges. Last month, my colleagues and I were exploring the Caribbean Trough in the Caribbean Sea, and we were diving with a remotely operated vehicle called ISIS, which you can see here. It's about the size of a family car. And one of our goals was to investigate the world's deepest known undersea vents, which you can also see here, 5 kilometers down on the ocean floor. The samples and data that we collected will help us understand more about the geological processes that shape our world and the reactions that govern the chemistry of the oceans. We also encountered new species of animals, and those will help us understand more about how marine life disperses and evolves in the ocean depths, which make up most of our living world. Our expedition was the latest in a series of voyages exploring deep-sea vents around the world, and just one of many such expeditions out there every day, gradually learning more about the deep ocean. Now, one of my favorite images from ocean exploration is called the floor of the ocean, and you can see it here. It's a map drafted by Marie Tharp and Bruce Heason in the 1950s. They pieced together echo sounder traces from ships crossing the ocean and produced for the first time a global map that showed the landscape of the ocean depths. And their work revealed the full extent of the Mid-Ocean Ridge for the first time. Today, we've also got global maps of the deep sea landscape from satellite data. But those maps can't resolve features smaller than a few kilometers across. So even now, there are still undersea mountains, seafloor craters waiting out there for us to discover them with sonar from ships. But sonar and satellites can't tell us what's going on down there, and they can't reveal what lives down there. For that, we need to send our eyes to the ocean floor. Fortunately, after millennia of crossing the ocean surface in our history, we now have the technology to visit its depths. From the pioneering bathysphere dives of William Beebe and Otis Barton in the 1930s, the record-breaking plunge of Don Walsh and Jacques Piccard in 1960, through decades of dives by research submersibles, such as the famous Alvin that you can see here, to the latest generation of remotely operated vehicles like our ISIS, along with autonomous underwater vehicles, new human-occupied vehicles. There's no longer any part of the deep ocean that's inaccessible to us if we can find the will to go there. Now, when Project FAMOUS visited the Mid-Ocean Ridge for the first time in the early 1970s, the Alvin submersible spent a total of 81 hours working on the ocean floor down to a depth of 3,000 meters. That was an astounding feat at the time, and it heralded the mainstream use of deep submergence vehicles for scientific research. During our recent expedition, our ISIS ROV spent nearly 200 hours working on the ocean floor down to a depth of 5,000 metres. And while we're very proud of that achievement, it's now routine. It also illustrates some of the options that technology has given us for exploring the deep. We can boldly send our bodies there in human-occupied vehicles, but now in the 21st century, we can also just send our minds there through remotely operated vehicles, whose high-definition cameras become our eyes, whose dexterous manipulators become our arms for working on the ocean floor. Now, our newfound ability to peer into and investigate the ocean depths could not be more timely. Our everyday lives have an impact on the deep ocean. When we're visiting new areas of the deep ocean with our deep diving vehicles, we often find that our rubbish has already got there before us. This image from the bottom of the Caribbean Trough last month. Meanwhile, we're extracting oil and gas on which our economies depend from deeper waters, but we're still learning about the consequences of accidents in those operations. We're also fishing in deeper waters, and we're trawling remote areas where marine life has yet to be surveyed. And now we're also starting to unlock the mineral wealth of the deep ocean. The long-held dream of harvesting manganese nodules from the ocean floor is finally starting to become a reality, with the first extraction project starting up in the Eastern Pacific. Elsewhere, the deep-sea vents that have inspired our ocean exploration so far are now within reach for the deposits of metals, like the ones you can see here, that form around them. In the past 2 years, the International Seabed Authority, which is the United Nations body that governs the seafloor mining in international waters, has awarded 4 new licenses for mineral exploration that span several thousand kilometres of mid-ocean ridge. So in just 6 decades, we've gone from not knowing about the full extent of the mid-ocean ridge to visiting it for the first time and now parcelling up its resources. When Marie Tharp and Bruce Heason first glimpsed the full extent of the mid-ocean ridge in the 1950s, our global population was just over 2.5 billion people. When Project Famous first visited the mid-ocean ridge in the early 1970s, it was nearly 4 billion people, and today it's around 7 billion people. Now, those numbers only tell part of the story, of course, but as our growth and development continue, the deep ocean offers us a challenge. If we can act quickly, use our new powers of perception, we can decide how to benefit from the resources of the deep ocean while still fulfilling our responsibility for its stewardship. Our species has a poor track record of achieving that balance elsewhere, so let this be our new testing ground. Now that the deep ocean is no longer out of sight, it's our choice whether its future iconic images will inspire or shame us. Thank you for your attention.